All right, today we're going to talk about is projectile motion, and this is applications of it, and it's important that we are not using calculator or Desmos. We're just doing all of this by using quadratic equations and interpreting what each part of that means. So let's get started. There's a couple pieces of information that when we're looking at any applications of quadratics, that one of the questions or things that we might be asked to do is to determine when the object will reach its maximum height. So the key word here is when. When is typically going to be your x value, and maximum is your vertex, because that would be the highest or the lowest point, and in this case, since it's maximum, it would be the highest point. So when it says when and maximum, that's your clue words to say you're looking at the x value of your vertex. And to find that, you would do the axis of symmetry, which is x equals negative b over 2a. Now, to find the y value of the vertex, it's going to say what is the maximum height. So in this case, the what in maximum would tell you it's going to be the y vertex. So remember, you take whatever your axis of symmetry is, and you're going to substitute that in for x of your equation to find y, and that's going to give you the vertex. Now here's this picture. So in this case, this is your vertex, which is the maximum. You have your x right here, which is the when. You have your y right here, which is the what. And then you're going to do another part, which is the initial height. So the keyword here is initial. And for initial, that means the y-intercept. So you're going to look at the c value. So what that means is where it crosses the y-axis. So it's the y-intercept, that's when it starts. So when they threw this, it started here, and then that's the maximum. And then the object is going to come down, and when it hits the ground, that's the x-intercept. And to find that, remember that's what we just talked about, was you factor it and then solve it, equal it to 0, solve it. So these are all the parts, the major parts, and then of course it, depending on what's happening in the word problem, you make adjustments as needed. But let's get started with this one. It says an overzealous golfer hits a shot with a sand wedge to get out of the corner of a sand trap. The path of the ball is modeled by h of t equals negative 6t squared plus 80t, where t is the time in seconds and h is the height in feet. So when you're looking at this, your graph, if I were to sketch this, and I'll just kind of do a sketch here. So since it says h of t, that means t is time. And then we said height, which we said was h. So if we were to sketch this, that's what would be happening, t in seconds. And then it says, what's the initial? Well, if we're starting, then the ball is going to start on the ground at the y-intercept, which makes sense because if you're to look here at your equation, we know it starts on the ground because there is no c value, so it's plus 0. So we know that's where it starts. And then we know we're going to hit the ball. And I'll just do a black little, let's see. And the maximum, or the vertex, is right here. So to find that, we need to know a couple pieces of information. When does it reach its maximum? So that would be here, and when is your time. So you're looking for your x value of your vertex. So you're going to plug in. So negative 80 is b over 2 times negative 16, which gives you negative 80 over negative 32. And this one we can keep as a decimal, that's fine. It's 2.5 seconds because we said that was our time. So that's the x value. Now that we've got the x, we're going to take our original equation And we're going to substitute it in. Now, they had t, so, but remember we said t was your x anyway. So we're going to substitute this one into each of your values. And remember, when you do this, it's going to be 2.5 squared first. Then you take that times negative 16. And then do that. And once you plug it all in, you're going to get y equals 100. So your vertex in this case is going to be 2.5, comma 100. And then now let's go ahead and let's look, because we've answered this. We've got our vertex here, our x and our y. Now we want to know, when does it hit the ground? Well, when it hits the ground, it started here, but it ended here. So we're looking to figure out, what point is this? Oops. All right. So when it hits the ground, we want to know what our x-intercept is. So the x-intercept is where you set the equation equal to 0. And first we're going to look for our GCF. And in this case, we actually have a GCF of negative 16x. Because remember, you want to get this positive. So we're going to factor out a negative 16x. And then when you divide each term by negative 16x, your leftover is x and minus 5. So we're going to set this equal to 0. And that's going to give you x equals 0. And then we're going to set this equal to 0. And that's going to give you x equals 5. Now, we're not going to use this one because that's where they started. They wanted to know, after he hit the ball, when did it hit the ground? So we're going to use this, which is 5, 0. All right. I'll do it a little bit thicker. There we go. So that means 5 seconds is going to be the best, or is going to be the answer that we're going to use. So we're not going to use that one because that's over here where they started. We want to know when it hit the ground. All right, so it's just interpreting what you need to do. And then I usually try to sketch out a picture of what's happening, and that kind of helps me know what I'm looking for also. All right, so let's look at this one. This one says a company sells widgets. The amount of profit Y made by the company is related to the selling price of each widget X and is given by this equation. And again, if I were to sketch this out, all right, so I know right now a couple things. I know that my y-intercept is 1600. Now we don't have to be accurate because we're just doing a sketch of it. And I know that they're selling something. Now in this case, I don't know which one is necessarily X or Y unless it specifically tells me. So what it tells you right here is your X is your selling price. And then your Y is the profit. So again, once you kind of label it, you can kind of see what's happening. So in this case, since A is negative, I know it's going to go like this again. So for your for your what price is your X, and we want the maximize. So we're looking for our vertex right here. So we need to do axis of symmetry by substituting in B. So we get negative 400, and substituting in A, which is negative 50, to get negative 100, and that's going to give you $4. So this is your X value, so it would be X equals 4. So your axis of symmetry would be right here at 4. Or at 4, I guess I should say. There you go. All right, and then we want to know what is the maximum profit. So we're going to look at our Y, which is a vertex. So we're going to take 4, substitute it in, and remember, you're going to do this first, then multiply by negative 50, and then you multiply this, and then add them all together for 2,400. So your vertex is going to be right here. And then that's going to be the maximum, depending on what you're looking for. Then we want to know, what is the profit when the cost of a widget is $6.50? So we're saying, hey, if X equals $6.50, how much are you going to spend? So really, all you need to do is substitute in $6.50 for X. And then remember, do this first, then multiply by -50, multiply that, and then add them all together to get 2,087.50. Now in this case, it didn't ask for your x-intercept, so we don't even need to solve it. All right, so what I would like for you to do is go ahead and I want you to answer those questions. Now I did give you the answers for each one, except for the initial height, and that would be 144 because that's your C value. So, but I want you to show the work for each part. All right, and so the biggest thing when you're doing this is it says when and maximum, that's your X value for your vertex. If it says what maximum, that's going to be your Y of your vertex. Initial height is your Y-intercept. And then whenever it hits the ground is your X-intercept. Once you understand those, the rest is just following through what we've done before.